Okay, now galvanic cells. The next one, this is really just a very simple battery. So we know from this that we will have an E0 value that will be greater than 0 for the cell. That will mean it's spontaneous. Now, how to get started on this? Well, first of all, we know that the left-hand side for these is kinetic oxidation, and the right-hand side is reduction. It's just a systematic quality that we're doing this. When we look at these voltages, the more positive one is the one that gets reduced. So it means on this side, I'm going to be going from copper 2 plus, containing 2 electrons, and forming solid copper. It's because going this way is reduction, where going the other way is oxidation. If that's getting reduced, that means this is getting oxidized. The more negative voltage gets oxidized. So that's going from PB to PB2 plus. Okay, and the overall cell action therefore would be with both 2 electrons. Cancel out. And tripping starts. Okay, in terms of labelling it, now RedCat still works. So what RedCat is, reduction happens at the cathode. So on this side, this is a solid electrode, so that's going to be the copper. And in solution, we've got copper 2 plus ions floating around. And over here, solid electrode will be PB, and then have some of these ions floating around in solution here. Now, there are negative ions in the solution, and it could be things like sulfate and nitrate. And but we generally don't worry too much about those because they're not included in the reaction, but they are there. You cannot just have 4 positive or negative ions in solution. Now the salt bridge could have potassium ions in it, and nitrate ions, or it could even be something like sodium or sulfate. Just using writing question bits in there, or as a chemist what you choose to put in there. You choose to put in there that is very unreactive and that can involve either reaction. But now, this is a spontaneous reaction. And if we were to draw a standard cell, we really are just redrawing reactants and products and the salt bridge. So this will be oxidation on the left. So and on the other side we're going to have copper 2 plus and copper. Now there's a solid electrode at either end. So in the way it kind of works is you've got the reactant and the product. So this should match up. And you see PB here, we expect that to be a reactant, and it is when we look at the equation down here. And we also expect copper 2 plus to be reactant as well. Now, if we did not have a solid that could be used as the electrode, we would have to use a graphite electrode. Now, the only times it happens is when you've got things like Fe2 plus or Fe3 plus present, and there's notice there's no solid electrode here. However, if we have Fe2 plus and Fe, Fe is a solid, so that could be used as an electrode. So there would be no need to have a graphite electrode. Now, in terms of what's happening, as this reaction proceeds, Pb on the left cell is being turned into Pb2 plus ions. So we get a build-up of positive charge on the left-hand side. Now that will mean that the electrons that get released from the oxidation and want to move around the external wire, they won't be able to do that with negative electrons if that positive charge is building up. So through the salt bridge, we're going to get anions moving through. And in this case, the anions are nitrate. A kind of simple way of remembering it is that anions move to the anode. In any exam, that wouldn't be a sufficient answer. You have to explain why. That the charge, positive charge, is building up. diffusion Pb2 plus forming, and the nitrate ions move out of the salt bridge to maintain charge neutrality. It's got to be neutral. Most electrons can't move, and we get this complete circuit. So there's kind of an external circuit going through the wire where the electrons move, and then an internal circuit which is through the salt bridge. Now, at this stage I actually haven't mentioned what's going on the right hand side. So if I was to do that, that would be a little bit different. So I'll just get rid of this. And on the right hand side, what's happening is copper 2 plus is forming solid copper. So copper 2 plus ions are being consumed. It means there's less positive charge, and that really means that effectively there's more negative charge if you're taking away the positives. So it means potassium ions will move out of the salt bridge. Place them and maintain charge neutrality. So that's an important thing to be able to discuss in terms of the movement of ions. Okay? One other thing to remember is when you're talking about the ions, you don't really talk in terms of the concentration changing. This is all to do with charge, and that's what you should be talking about. Build up a positive charge would therefore mean, once it's on the left-hand side, that negative ions, in this case nitrate, move out of the salt bridge. And on the right-hand side, you get the opposite really. You've got copper 2 plus ions being consumed, so positive ions have to move out the salt bridge to replace those to maintain charge neutrality. How about electron movement? Well, the electrons move from the left to the right, so they go from the anode to the cathode. But that's a very simplistic way of looking at it. You should be able to explain it in terms of what's happening. As Pb reacts, it becomes Pb2 plus, it gets oxidized, it loses 2 electrons which move through the external wire, where they go to the cathode. And the copper 2 plus ions gain those electrons, and so get reduced to form solid copper. Okay, so I've just really described what's happening in terms of the electrons being lost and gained as they move from one side to the other in that process. Now you should also be able to relate this to observations. Now, if this is solid metal, it goes to Pb2 plus. Now really, the equations really help you with observations. Now, if that's solid and it's being oxidized, that electrode will decrease in mass. It's a grey electrode getting smaller in mass as the reaction happens. So grey solid electrode decreases in mass. Now it forms colourless Pb2 plus ions, so the solution will remain colourless. And on the right-hand side, this copper 2 plus is blue in colour. So I've just rewritten that to show some observations. The blue copper ions get consumed, so it becomes lighter blue. The copper electrode gets bigger in mass, and that's more of an orange, reddish colour that forms. So those are the observations. You should be able to link those to the species as well. Now, in terms of it being spontaneous, should be able to do the calculation. E0 cell is reduction minus oxidation. So it's going to be 0.34 minus 0.13, and that equals 0.47 volts. Now you must put the unit or else you'll get marked down, so make sure you do that. It is volts. Okay? Now, talking about that, you need to look at how the E0 cell that's greater than 0 will be spontaneous. Equals spontaneous, not that interesting, it's a shorthand, and therefore it produces electrical energy, and so electron produces electrical energy, and electrons are free to move. And what can be the next question? Now, relative oxidizing ability, we're making some comparisons here. You look at these voltages, and that's what this is really asking us to do. So the higher the E0 cell value, the stronger the oxidant. And therefore it will cause oxidation to happen as it is reduced. So in this case, one of the things you can't really leave out is obviously this is the biggest voltage here, but we can't mention both of these. They can't both be the strongest oxidant. It's the one that's reacting, which is copper 2 plus, and is it getting reduced to there. So this is Cu2 plus. Being reduced, gaining electrons. Remember, it's kind of the opposite world where we name things, and it is the strongest oxidant because it causes something else to be oxidized. But it is in fact getting reduced. So it gets reduced, it gains electrons, so we call it the strongest oxidant. And that's because it's causing oxidation of something else. Okay? Now, one final thing, you should be able to talk about the oxidation reduction process in terms of change of oxidation number. That's going from +2 to 0, and it's going from 0 to +2. But you'd be talking about how the Cu in Cu2 plus has an oxidation number of +2. Let's look at that, +2, and goes to 0 in Cu, and that's a decrease, so it's a reduction. And you should be able to say a similar thing about Pb having an oxidation number of 0, while the Pb in Pb2 plus is an oxidation number of +2. It's an increase, so it's oxidation. So just be specific with what you're talking about, and always mention decrease or increase when you're talking about this to show you know what's happening, and then link it to the process involved. Just the same, you should be able to talk about the electrons. Copper 2 plus is gaining 2 electrons as it's reduced to form copper, and Pb, as it's getting oxidized, is losing 2 electrons to form Pb2 plus. And that's the basics of galvanic cells.